Welcome to our talk on Prometheus 3.0. If you have any questions, feel free to scan this QR code, and we will answer questions at the end of this presentation. My name is Carrie Edwards. I'm a staff software engineer at Grafana, and I'm a Prometheus maintainer and team member.
Hey everyone, I'm Gautam. I'm a product manager at Grafana Labs. I'm also a Prometheus team member.
We're going to start off with a show of hands. Who here has heard of Prometheus? Okay. And who here has tried out Prometheus 3.0? Okay, a couple of people. Great. Since everyone seems to be pretty familiar with Prometheus, we'll skip over the basic intro, go over the history. So Prometheus started off at SoundCloud with the first commit about 12 years ago. And in 2016 and 2017, it became the second project to join and graduate from the CNCF. Version 2.0 was released in 2017 with major updates to the TSDB. And last November, we had our first major release in 7 years, Prometheus 3.0, which will be the focus of our talk today.
I was just looking back at when I did the 2.0 release, and 2.0 was how I started my career, and I'm really glad to be kind of here also talking about 3.0.
So today we're going to talk about some of the features that have been released as part of Prometheus 3.0, which includes the new UI, native histograms, OpenTelemetry compatibility, UTF-8 support, remote write 2.0, and some breaking changes. There have also been several updates and minor version bumps since Prometheus 3.0 was released, so we will also talk a little bit about some of those new introductions, as well as what's to come in the future. So let's start off with one of the most discernible changes introduced in Prometheus 3.0, which is the new UI. The UI was completely rewritten by Julius Volz, and it introduces a less cluttered, more consistent, and easier to navigate layout. This QR code will take you to a demo so you can try it out for yourself. The old Bootstrap-based system has been replaced with React and Mantine framework with a goal of a more modern look and enabling better development and easier maintenance. There's also been many new features that have been added as part of the new UI. One of the key features is the new Metrics and Label Explorer, which can help you build your queries. You can view and search through available metrics and metadata for each metric. Then you can select a metric, and you can use the Label Explorer to drill down into the label names and values of the specific metric and add label matching filters to narrow down your desired result. This is also a feature that exists in Grafana if you use Grafana UI. You can also use the query tree view, which was adapted from PromLens. This allows you to break down any PromQL query into sub-expressions and includes inline documentation and metadata so that you can see what each part of your query is doing. You can click on each of the nodes and see what it evaluates to, and also what label data exists in each sub-expression. The Explain tab can give you even more context on a node within your query with explanations, insights, and visualizations. Here, the Explain tab is visualizing how you're joining the series together by describing the match groups on the left and right-hand side of the binary operator. And the Explain tab can also make debugging a lot easier by providing explanations and visualizations of what is going wrong with each part of your query. This is a feature that Grafana does not yet have, but hopefully it will in the future. Looking ahead, there's continuous work being done on the UI. And there's been a lot of work on graph views already to improve them, such as adding vertical lines and clipboard functionality. There's still more work to come here. And there's also some in-progress work on UTF-8 quoting and auto-completion and rendering native histograms and heat maps. And next, we're going to talk about native histograms. So in general, histograms store distributions of data points rather than raw data by storing counts of values that fall between certain ranges, and they're often used for quantile estimation. Historically, if you wanted to measure things like latency of requests, in Prometheus, you would use classic histograms. Classic histograms require predefined bucket boundaries, and they're represented and stored as multiple time series in Prometheus, one for each of the buckets, as well as one for the count of the data points and one for the sum of the data points. But there's quite a few drawbacks to classic histograms. When it comes to defining the bucket boundaries, it can be difficult to determine ahead of time what would be appropriate bucket boundaries for the data, and you may have to change it over time. And when you do have to change it, it requires reinstrumentation and redeployment. It's also quite expensive to store buckets because each one results in a new time series. They also take up a lot of space. And because of this, many users will define only a few coarse buckets, and this can cause inaccuracy in quantile estimation. Also, classic histograms can only be aggregated if the bucket boundaries match exactly. We now have native histograms, which address a lot of the issues that classic histograms present. Instead of having to predefine the bucket boundaries, the boundaries are calculated based on an exponential scale. And this allows for native histograms to be aggregated and merged together more easily. And the other big benefit is that instead of being stored as multiple time series, stored as a single complex sample that encompasses all of the data that you need. Here is an overview comparing classic histograms and native histograms. But the key takeaway is that native histograms are a huge improvement in efficiency for both cost and space. Here's an example of querying native histograms in the Prometheus UI. This graph shows the bucket counts of a native histogram and the boundaries of each of the buckets. And here's an example of quantile estimation. This graph shows the 50th percentile of a native histogram sample. Note that there's slight differences in querying native histograms versus classic histograms. For example, you don't need to use the LE or less than or equal to label when you're querying native histograms. Looking ahead, there's a lot of exciting things to come for native histograms. There's also been a lot of updates since the release of 3.0, and there's still refinements being made in the text format and the operators and function refinement, and heat maps in the UI, another feature to come. And there's another exciting new feature that is in progress with native histograms, and that is custom buckets. Native histograms with custom buckets address the scenario where you might have a native histogram that doesn't fit your data very well. It could be that exponential scale don't fit the data, or it could be that you have legacy code you cannot change the instrumentation of. So native histograms with custom buckets allow for storing data in a single time series, but also using predefined bucket boundaries. And this means that you can convert classic histograms into native histograms with custom buckets without losing any accuracy or any loss of data. And this can happen at scrape time, so you don't need to re-instrument. All right, next we're going to talk about Remote Write 2.0. Remote Write is a protocol that allows Prometheus-compatible senders to forward scraped metric data in real time to receivers. Prometheus can send and receive this data And other monitoring tools such as Thanos, Cortex, and Mimir can ingest the data and then forward it to their own TSDBs, or write it to their own TSDBs. This protocol has been widely adopted by other open source projects and vendors, and it's been very useful for real-time metric streaming. The initial version was Remote Write 1.0, which sends data using snappy encoding, protobuf messages over HTTP, and also uses back-off retry semantics based on the receiver's response codes. Remote Write 2.0 improves on the efficiency and network bandwidth and supports newer Prometheus features. It still uses the protobuf over HTTP, but now it sends data by string interning all of the label data, and this dramatically reduces the request size. The spec also includes fields in the data for new features in Prometheus, such as native histograms and created timestamps. And there's also support for handling situations where there's a partial write failure. So receivers can respond with the partial write error statistics for different types of samples using HTTP headers, and senders can use these response headers to log the errors and retry according to the code. Here you can see that massive improvements in efficiency on bandwidth and serialization levels with Remote Write 2.0 compared with Remote Write 1.0. And in order to make Remote Write easier to adopt in the long run, we have built an experimental library in client Golang, and this allows you to construct Remote Write 2.0 compatible senders and receivers more easily without having to manually ensure compliance to the spec. Looking ahead for Remote Write, the goal is to soon market as non-experimental, and there's continuous work being done for sending creative timestamps and addressing efficiency issues with metadata. And one of the benefits of this flexible new protocol is that we can experiment with various compressions and even formats like Apache Arrow in the future. All right, now I'm going to turn it over to Gotham.
Thank you, Carrie. Yeah. So I haven't actually written any code for 3.0, but I did do some other work, like spec work, and like OTel support is one of those. Yeah, again, OTel is gaining adoption. We really like OTel, and if you go back just a year, using OTel with Prometheus was not great. Well, it was painful. But over the past year, we've had a huge push to support OTel natively in Prometheus, and yeah, you can now push metrics into Prometheus, and I'm having like weird feelings when I said that, but you can. Yeah, you can basically just post the OTel metrics from your applications that are instrumented with OTel into Prometheus. However, again, we don't want to default on this because that will allow people to push random data into Prometheus, so you have to explicitly enable it with this feature flag, but it is stable. Having said that, the spec for converting OTLP data into Prometheus is still in flux. And by default, if you just follow the spec, everything that's a resource attribute, like namespace, cluster name, and things like that are sent into a different metric that you have to join on to kind of group things. And this makes queries really hard, so we also added a nice config option called promote resource attributes that you can kind of pick to just copy over these resource attributes into labels, and then you can use these labels normally, just like you do with Prometheus data. Yeah, by now, I mean, like for now, you just copy paste a snippet, and all the most common OTel resource attributes will just be copied as labels. But we are working on making the spec better and actually doing it automatically without any configuration. The other thing is something that Matt alluded to, which is UTF-8 support. So we really like OTel, and in OTel, they use dots, so, which we did not support. So we were like, OK, let's just add dots. And then we read the spec for OTel, and they said, no, we also support slashes and anything UTF-8. So Prometheus can now do UTF-8 metric names and label names and label values. Yeah, you can kind of see, you can use emojis and labels. However, you can also use emojis in metric names, which means you can have a metric that is the graph emoji, and then you can graph the graph emoji. Um, I really like OTel, but sometimes to follow the spec, we have to do things that I don't like. But yeah. Yeah, so again, this is implemented in the server. And a few of the client libraries, we need to enable UTF-8 support everywhere. Like the Ruby maintainers are looking for help. So if you're a Ruby expert, we would love your help. We also want to use the type and unit metadata in OTel very well. For example, if you're trying to do a rate over a gauge, we want to tell you, hey, this is a rate over a gauge. Don't do that, and things like that. And we also want to understand semantic conventions. So if we see a HTTP metric, we want to automatically generate some insights around it, for example. Yeah, we also want to support delta temporality. In Prometheus, the only thing that we support is cumulative. So we kind of, if you're graphing the number of requests, it is basically, we always store the total number of requests that we've seen so far. However, if you're familiar with statsd, it just pushes deltas, or like Datadog, they push deltas, and OTel has the ability to push deltas, and we want to support them well. Well, we kind of hacked it into Prometheus with a feature flag. Well, we are not really happy about that implementation, and we want to kind of natively support deltas. We still don't know how to do that, but we're figuring it out. Yeah. Putting it all together, you can kind of see a native histogram from OTel. There's a few dots in the metric name. There's also an underscore in the metric name, just because. And yeah, we're kind of evolving all of this to make it consistent. But today, you can push OTLP, semantic conventions, and native histograms into Prometheus and graph them with PromQL. I think that's really cool. And here comes everyone's favorite feature. I kind of want to say we have no breaking changes, but then I'll get to the next slide, and we'll have a huge page full. However, these are only breaking changes that we think or we thought affected extremely few people, and these few people, like, they can easily change them. So these are not really like stop the world breaking changes, and we wanted upgrades to be seamless. For example, how many of you here use the hold winters function? There you go, we broke it. So things like that. And then we actually ended up breaking people. So how many of you understand what this does? OK, very few people. Well, we broke you too. So essentially, what this does is it just, the first 1 minute says, get every, like, kind of run a query that gets foo for every 1 minute, like get a data point every 1 minute, and then select the last 1 minute, and then you can do a rate on it. Before, we used, before we used to kind of include both the first and last point, and in rate, you need 2 points to calculate the rate. Before these queries used to work, and then for consistency and efficiency, we kind of said, oh, actually, it doesn't really matter if the last point is included, because how often is it to kind of have a 1 minute window and 1 minute scrape interval, and it all just lines up to the milliseconds. Well, if you use Grafana for caching, it lines it up to the milliseconds. So things that used to work before did not work. Well, this we have no fix for. Just don't do this, where everything is lined up just 1 minute, or 5 minutes. The other thing is we have something, basically, we kind of, when we scrape, we say, hey, what protocols do you support? And if we find something that we did not really understand in the answer, we just used to default to like Prometheus text 004. And we were like, oh, actually, that's very, very old. Let's just default to something else. And then only if we don't understand the protocols that are supported. Turns out Sinatra, I think, which is a Ruby client, sent us commas instead of semicolons. And before it used to work, and then it didn't work. So we kind of broke those users. They fixed it. But if you run into this issue with Sinatra, maybe you can still kind of configure this. All right. The next thing has nothing to do with Prometheus 3.0. It has been my pet project for the last 2 years. I thought it'll take me 3 months. Well, 2 years later, here we are. So if you kind of look at it, this is the number of commits over many, like multiple versions from 2.5 to 3.0. In 3.0, we have a lot of things. One thing is that these graphs are more or less consistent. And this just shows that Prometheus is still a very active project. But again, I became a PM, and I was like, all my metrics need to go up. So one of the things that we noticed is while we have a very healthy and active project, we have failed to kind of attract new leadership into the project. This was basically limited by our current governance, which just says to change the governance, we need 2/3 of the majority to kind of agree to this change. So as we kind of increase the size of the governance, achieving this majority becomes harder and harder. So we just like, as the number grew, the bar got higher. So for the longest time, we added very few people. And again, I kind of wanted to change that and get to like 1 million maintainers. We'll see if we'll get there. But yeah, first thing we did was we actually looked at all the active maintainers and added them so that they can vote for the new governance. It's kind of funny. It's like, hey, come on in. In 3 months, you're not part of team anymore. But yeah, well, it's been 6 months, I think, now, and they're still part of team. But yeah, like, we have 22 new members, and they're not new, actually. They have been consistently contributing to Prometheus for many, many years. And we've just decided to just just add them all. Well, shout out to every single person and all the contributions that you've and everyone has made. Cool. So, yeah. So yeah, I've been working on Prometheus Governance 2.0. That kind of looks like this. Everyone who did anything, including doing a thumbs up on the release page, is a contributor. You are a contributor to Prometheus. If you've contributed, clap for yourself. And then, yeah, there you go. And then, yeah, anyone who is kind of maintaining repos or sub-projects or folders, like they are maintainers. No, wait. OK, sorry, I missed the member part. Yeah, if you have like 10 contributions over like a 36-month period, we will add you to the GitHub org, so you can become a member. You can have a lot more say in the project, and you can also kind of brag about it. So we want to kind of increase the number of people that can call themselves Prometheus org members, and this is something that's important to us to kind of have a nice stepping stone before you become a maintainer. And then maintainers are those that have like commit rights and push rights, and basically they maintain the different exporters, client libraries, and different parts of the Prometheus and Alert Manager server. And then the members will elect a steering committee of 5 to 7 people, and the steering committee basically has the right to change the governance. So we can have like 1,000 members having a say in everything without actually deadlocking on the governance. Well, this is kind of approved. However, we are still figuring out how to vote for the steering committee. So we're going to have a vote to figure out which voting mechanism to use. And yeah, so that's kind of where I'm stuck. It's like the last 5% is taking 95% of the time. With that said, I don't think you should wait for the new governance to get involved. Just get started now. We are still adding maintainers. We're still adding new members into the team. And we have a lot of work for you, especially all the work that we've started with 3.0, and we actually never finished any of those. So there's a lot of work and a lot of different channels on the CNCF Slack. Just search for Prometheus in the CNCF Slack. You'll see a lot of different channels. If any of these sound interesting to you, basically just reach out and say, hey, I have some free time. I would love to contribute. How can I contribute? And we can kind of walk you through this.